In this video, I'll be talking about increasing, decreasing, and constant, and relative minimums and maximums. So first of all, we say a function is increasing on an interval of x values, that is, if it rises from left to right. Another way to say that is as x increases, y increases. So it's pretty intuitive. So you can see that this function here from left to right is rising, and so we could say it's increasing on whatever interval in here we want to use. And so that's an example of a function that is increasing on an interval, certainly in between a and b here. We say a function is decreasing on an interval of x values if it falls from left to right. So an example would be something like that. Well, something like that. All right, so another way to say that is as x increases, y decreases, or the value of x increases, the value of y decreases. And then finally, we say a function is constant on an interval of x values if its value is constant. So no matter what x is, no matter what my input is, my output is always the same. Another way to say that is as x increases, the value of y remains the same. Now, down below, they have a formal definition, which is the kind of thing you're going to see if you go on to a calculus course. So I just want to introduce this to you here. And you can give this kind of definition for any of these and what we're going to be doing next. So let's see if we can make some sense out of this. A function f is said to be increasing on an open interval I. So let's go ahead and call this our open interval of I. If for all values a and b in the interval, a less than b implies f of a is less than f of b. So if for all values a and b in the interval, so these are just two specific points that I picked where a and b are in this interval I. And let's look at f of a and f of b. So notice in this case, you can see that f of a, which is this distance here, that's the y value, or that distance there, the vertical distance, is less than f of b, which would be this distance. And no matter where you chose your a's and b's, as long in this interval, as long as a is less than b, then f of a will be less than f of b. So that's the idea. All right, let's go ahead and move on to the next slide. So we're going to talk about relative maximum and minimum values. It says here, these occur at peaks and valleys on the graph of a function. A relative maximum or minimum is the y value at such locations. So it's the y value that's actually our maximum or our minimum. All right, so if you look at the first graph here of f of x equals minus x squared plus 1, you can see that we have a peak right there at the point 0, 1. And so it's the highest point, and at that point the y value is the highest on this graph. And so this is a relative maximum. In fact, we would say it's a relative maximum of 1, that's the y value there, and it occurs when x equals 0. All right, so let's go ahead and look at the next one here. So here we have a lowest point, and if you look at all the points on this graph, the y value will be the smallest at this point. And so this is a relative minimum of -3 when x equals 2. So I would encourage you to try the next one. You actually have a relative minimum and maximum, and then watch the video. All right, so there's your two relative, well, the one on the left is your relative maximum, and the one on your right is your relative minimum. So notice we have a relative maximum of 1 when x is equal to 0. Again, it's the y value, and it occurs when x is equal to 0. We have a relative minimum of -3 when x equals 2. So that's right here. All right, so I do want to point out something here. Notice even though this is a relative maximum, we have points that are higher there. So what we're really saying is in this region, that's the maximum value of the graph. So we say it's a relative maximum. It's not actually the absolute maximum, which is what we don't, in this case, we don't have an absolute maximum. Our main focus here is going to be relative minimums and maximums. But I do want to point out, if you look back at this graph, let's see, no, that's not the right one to look at. Actually, I think that's all I'll say for now. I guess I could say on the first graph here, notice we don't have, oh, I know what I was going to say. What I was going to say is this is actually an absolute maximum as well. So it is a relative maximum, but it's actually the largest y value on the whole graph, so it's actually also an absolute maximum. But again, we won't worry too much about that. Our focus is on relative minimums and maximums. All right, so let's talk about where we're increasing or decreasing. So now I think if you look at this first graph here, you can tell on the left we're increasing right here, and on the right we're decreasing, again, as you go from left to right. And so it's pretty easy to tell where you're increasing or decreasing. It's just the way we note it, you got to be careful. Because what we're going to say is over what interval of x values are we increasing or decreasing. So this is how it works. So you can see we're increasing here, and this occurs when the x values go from -infinity until they get to 0. And then now we're at 0, that's like a turning point. From here on, we're decreasing. And so from when x goes from 0, and then from now on, so when x goes from 0 to infinity, this graph is decreasing. And so these are intervals of x values. And one of the things I want you to notice is at 0, we use an open parenthesis. And the reason why is we're not increasing or decreasing at that turning point. We're like in the middle. And so we'll always use parentheses when we're describing where we're increasing, decreasing, or constant. All right, so I would encourage you to try the next one. Well, actually, let's do the next one together, and then you can do the last one. I like to work from left to right. Now you can see, first of all, we're decreasing. So when this graph starts out in -infinity land, when x is really big negative, until x gets to 2, this graph is decreasing. And then from 2 to 4, you can see the graph is now increasing. So when x goes from 2 to 4, the graph is increasing. And then finally, we're constant. So we're increasing, or I'm sorry, we start out by decreasing from -infinity until x gets to 2. And then from 2 to 4, now the graph's increasing. And finally, it's constant from 4 to infinity. So again, I like to work left to right. I think that makes it pretty easy to do, but it really doesn't matter. So now go ahead and do the last one if you haven't already. All right, so you should have said we're increasing, and then we're decreasing, and then we're increasing again. So we're increasing when x goes from -infinity until x is equal to 0. And then from 0 to 2, notice the graph is decreasing. And then again, we're increasing again. It's from 2 to infinity. Now, sometimes people will put a union symbol in between here. I believe in our book they're just putting a comma. All right, let's go ahead and move on to the next slide. So this problem here I would actually like you to try, and it'll give you a review of what we just did, and also you can do D and E, which are review problems, and then watch the video. All right, so let's see how you did. Now the domain, if you look at the leftmost point, there is no leftmost point, and notice there's no gaps or anything. We don't skip anything, we don't have any holes or gaps, and then we go forever right. And so our domain is going to be all real numbers. What about our range? Now remember with range, see with domain we were going left to right because we were moving along the x-axis from the lowest to the highest values. And so the same thing's true with range, except for now we're looking at y values. So we'll go from the lowest point to the highest point, and now we're looking at y values. Well, we don't have any lowest point, but at our highest point, notice the y value is 6. In fact, there's no other point on this graph that's going to have a bigger y value than this point here. And so the range is -infinity to 6. And actually, I need to fix this because that point is on the graph, and so this should be a bracket. It's part of the range. That point is on the graph, and its y value is 6. All right, let's see what else do we have here. Hold on, let me erase this here. Okay, so it says so now we're going to talk about where we're increasing, decreasing, or constant, and that's what we were just doing. So you can see we're increasing from -infinity until x equals -1. And then we're going to be decreasing when x goes from -1 until we get to 4. And then finally we're going to be constant from here forward when x goes from 4 to infinity. All right. Let me change colors here. So any relative minimum or maximum values. Now, none of these are considered minimum values because it would have to be just one point where we have a single minimum value. So there's no relative minimum here, but we do have one up here at the top, and we know it's the y value of that point, and so we do have a maximum value, a relative maximum of 6 when x is equal to -1. And now finally, f of 0, you should have said is equal to 4. Now, there's two ways you could have approached this, and we had talked about this. So this is where x is equal to 0, and the corresponding point on the graph that has an x value of 0 is right there, and the corresponding y value is 4. And so we can say f of 0 equals 4. Now the other way to think of it is when x is 0, what's the height of the graph? Well, we're up 4, so f of 0 equals 4. So f of -3, the next one here, you should have said is equal to 2. So notice this is where x is equal to -3, and the height of the graph is 2 there. It's up 2, and so f of -3 is equal to 2. Now again, the other way to think of it is, this is the point on the graph that has an x value of -3, and the corresponding point, or output, is 2, or y value, whatever you want to call it. All right, so that's going to be it for this video.